Okay, watch. This is number 1, and we are trying to find the circumference of the circle. Shh, let's listen now. The circumference is pi times the diameter, correct? So what do we have to find? The diameter. Well, the diameter is kind of already drawn for you, isn't it? Right there. That would be considered the diameter. You could do this without really even thinking that much. What kind of a triangle is this? Okay, they give you that right angle right there. It's a 90 degrees. But look, I've got a 9, a 12. Look, what divides into 9 and 12 evenly? 3. 3 goes into this 3 times. 3 goes into this 4 times. So really, what is it? It's a 3, 4, 5 triangle, right? But it's 3 times 3, 4 times 3, and what? 5 times 3. So what's the diameter? No, the diameter is 5. I'm sorry, I lied. Right, 3, 4, 5, but it's times 3, which is 15.
You always reduce the size?
If it reduces, you can't always reduce them, but if it does, yeah, you recognize it's 3, 4, 5. You could have done it another way, but it would have been a little more lengthy, and that would be doing what? Pythagorean theorem. And you still get 15. It doesn't matter how you do it. I'm just trying to show you a little easier way to do it. Would you agree? So that's 15. So what's the circumference? The circumference is pi times the diameter. We don't write it like that. We just write it what? 15 pi. Now, how did I say to write the answer? As an exact answer. That's what I'm talking about by writing it as an exact answer. Even though I told you out loud in class to write it as an exact answer and write it right next to a pi, even though on the test it says write it as an exact answer, I still had people that have to put this into a calculator for some reason and get a calculator answer. It's a waste of time. I told you to write it as an exact answer. That's all you have to do, and you're done. You go to the next problem. You understand? It's trying to make it easier for you, and some people just refuse to let me make this easy for you. I don't know why. But anyway, you write it 15 pi, and you're done. All right, let's look at number 2. Okay, look at this. This is actually, I don't know if it's less work. It probably is. It's probably even less work. And a lot of you guys made this more difficult than it needed to be. This is 3 and 3, and this is a 90 degree. What kind of a triangle do I have? As far as my angles, 45, 45, 90. What do we know about a 45, 45, 90? That the hypotenuse is what? Square root of 2 times one of the legs. So look, I hardly had to do any math at all, did I? I mean, I wouldn't even consider that any math. So what's this diameter right here? It's just 3 square root of 2. Again, some of you guys are giving me square root of 18 because you did Pythagorean theorem, and that's okay. I mean, it works. But it's a lot easier just recognizing it's 45, 45, 90 and just making that 3 square root of 2. That's why we learn those special triangles. Make sense? All right, so that's 3 square root of 2. So what's the circumference then? Well, it's pi times 3 square root of 2, and I just write 3 square root of 2 pi. Now, why would you say a decimal? Had a big, long talk about this.
No, I said 4.2 times.
I know. Again. Why would you do that? I don't understand why. What's the purpose in making that into a decimal?
It's easier for me to read decimal.
Why? How is it easier? Okay. Well, I'm saying, but on this right here, though, I wouldn't change this to a decimal, would I? I would just leave it like this. There's no reason. We listening? There's no reason to change that to a decimal. I just don't understand what the fascination is with the calculator. Leave it like this. Even doing Pythagorean theorem, you would have gotten the square root of 18. Don't change that to a decimal. Just keep it square root of 18 pi. That would have been okay. I didn't ask you to simplify it. Okay? That would have been fine just like that. I don't see any reason why you would have to use a calculator on this. All right? Am I convincing anybody at all? I don't understand why that's so hard to convince you to leave it like this. Because to me, it's easier. It's less work. It's less you have to do. Nobody agrees with me on that?
I agree.
Do you? You just doing that just to get me to shut up? I think so. Okay, here's our picture. Let's see what I tell you what, let's see what they tell us first, and then we'll write down what we're trying to find. So they tell us that angle QRS is 40 degrees. So we'll mark that in a second. And then angle SRT is 90 degrees. And they're asking us for some things. Number 3, they ask us for arc XQ. And for V, that's my next one, VSX, they ask for that arc. And then number 5, they say find the what? Find the length of arc XQ. So number 3 and number 5 are not the same question, are they?
Yeah.
On number 3 and number 4, they're finding the measure of the arc. So what's my answer going to be in? It's going to be in degrees. That's right. Okay, I'm looking for degrees. I can't tell you how many tests I saw where, I think on number 5, I saw degrees on this, and I saw like no degrees on this one. You got to know what they're asking for. Okay, we've talked about that at the beginning of the chapter. We talked about what they want when they see an arc over top of it. I mean, the measure of the arc means you find it in degrees. Okay, so let's put some stuff in here. Let's color this up a little bit. Okay, QRS, where is that? QRS, that's 40 degrees right there. SRT, that's 90 degrees. That's 90 degrees right there. Okay. Yeah, if that's 40, then this is going to be 40. If that's 90, this would be what right here? I know it doesn't look like it, but that would be 50, wouldn't it? All right, and what's this big old arc right here, or angle right there going to be? Because this is 90 degrees. It's 90 degrees, 40 and 50 is 90. So if that's 90, that's 90. What would this R be? Let's get rid of that mess. So give me a number. 140. Okay, that's what that would be right there. Make sense? All right. So let's see what we want to find. Arc XQ. Arc XQ. Oh my goodness, this is so easy now. Once you find this angle, what's arc XQ? It's the same thing. This is central angle, isn't it? So if this is 140, then this arc has to be 140. All right, easy, right? VSX. Where's that? VSX. Ooh, it's this big old thing. Watch, from V, I'm not going to try to trace around this whole thing. I'll just be real sloppy. That right there. That's what we're trying to find. From here to here. So really, it's not that hard because it's what? You could add them all up, but it's easier to do this. The whole thing is 360. Back up how much? 40. So what's that give you?
The following teams are dismissed.
320.
Middle school baseball,
Okay.
middle school softball,
Make sense?
and middle school
So
boys
look,
lacrosse.
Your
Thank
only
you.
work is 360 minus 40, and that gives you 320. Right? Not hard. Now, here's the one that some people struggle with, the length of XQ. So here's arc XQ right here, and how many degrees is this arc? It's 140. It's 140 out of what? 360. Now, if we're going to find the length of the arc, think of the distance around the whole thing. That's the circumference, isn't it? So it's pi what? D, right, or R, right? Did they give us a radius? Oh, they did. Right, I didn't put that on here. They said if XS is 16. So they actually do give you the diameter, don't they? I forgot to write that down. So they do give you that. So it's pi times the diameter, right? Now look, on this one, it doesn't ask for an exact answer, does it? So you just chuck all that in your calculator, and you get whatever that comes out to be. What does that come out to be? I don't have it in front of me. I'll look on Leah's. Leah probably got it right. What number was that anyway? 5? Okay. 19.5? Is that what you got? Nobody playing along here? Okay, so 19.5. So put that all into your calculator. Once you put that in your calculator, you should get 19.5. And that's the length. Yeah. Yeah. All right, so that's how you do it. It's not so hard, is it? I don't think it's so hard. So far, so good. That was probably the hardest one we've done so far. Let's do number 6 now. Okay, here's number 6. Here's all the stuff that they give you. All right, they have it labeled and stuff, but I just filled it in. All right, just for time. So let's take a look at this. What are we trying to find? We're trying to find the measure of ON, which is the radius of the circle. That's O, and that's N. So that's what we're trying to find right there. Everybody see that? Okay. Let's just do this. Okay, that's what we're trying to find right there. Well, we got a triangle, don't we? Really, you only got to know like one thing. This whole thing is 16. What is it from here to here then? It's got to be 8. Because remember, if it's perpendicular to the chord, it bisects the chord, doesn't it? All right, we have a theorem that tells us that it bisects the chord. So this is 8. Look what we have again. We got a 6, 8, what? 10. That's right. It's a 3, 4, 5 triangle again. All right. Isn't that nice? 6, 8, 10, right? Because 3 times 2, 4 times 2, 5 times 2. And that is 10. And that's it. ON is 10. ON equals 10. Pretty easy. And then nice to know the 3, 4, 5 triangles. Yeah, because it makes it go quick, takes work out of it, and everything else. All right. Okay, look. On this one, There's basically one thing that you have to know about this. What haven't we used? Let's use this burnt orange. What is that? Oh, that's right. They mark it on the thing. H is 2x. Right. They do tell you that's 2x right in the picture. Let's draw the other things, and we'll talk about this. HGJ. HGJ. That's this one down here is 2x minus 10. And then IJG, that would be this one right here. That's 2x plus 10. Okay? Now look at this. Don't even worry about this one for right now. Just take a look. What do we know about a quadrilateral that's inscribed in a circle? There's something that you're supposed to know that we discussed. What do you think?
The two sides are supplementary.
Two sides are supplementary? The opposite angles, not sides. I'm sorry, I forgot to read your mind. Okay, so the opposite angles are supplementary. Okay? So that means they add up to 180. So guess what we're going to do? We're going to add them up, set them equal to 180. Okay, and then we're going to solve for x.
Where did you come up with these problems?
This is stuff that you had on the homework.
No.
Sure it is.
Do you create them or do you
No,
find
I find them places. I don't make them up myself. All right, so let's do this. It's 2x plus. So there's the 2x plus another 2x plus 10. What does that add up to be? 180 though, right? So that's 4x equals 170. What's that? Do that for me real quick.
42.5.
Okay, 42.5. That's not what they asked for, is it? I haven't even written down what they asked for yet. Yeah, they asked for angle GHI, which is just angle H, right? They could have. And they ask for arc JGH, all right? So let's find this angle H right there. Now look how easy this is. Look, this angle is 2x, isn't it? Okay, well we just found x. So what would that be? That'd be what? 84 plus 1, 85. So this is 85 degrees. Do you agree? Because it's just 2 times 42.5. So that's 85 degrees. That wasn't too bad, was it? But what you have to know, and the math was easy, but you had to understand that the opposite angles are supplementary. That's something you should have studied. That was part of what we learned in this chapter, and if you didn't go through it and look at it and at least say, oh yeah, I did look at it, but I forgot it on the test, that's one thing. But not even looking at it at all before you prepared for this test, that's another thing, all right? It just shows that you didn't prepare enough for it. You've got to go through. There's a lot of, I told you at the beginning of this, let's listen please and not talk while I'm talking. Thank you. When I first started this chapter, and probably several times through this chapter, I said there's going to be a lot of stuff. None of it in and of itself is very difficult. I don't think if you took one topic that we did, David, please don't. Okay, sit back, please. If you just take one topic out of this whole entire chapter, I don't think any of them are very difficult. But the thing is, I told you at the beginning of the chapter that we have a lot of different theorems and a lot of different relationships between angles and arcs and sides and all that kind of stuff that you're going to have to keep them straight. I told you that at the very beginning. Okay, and looking back on it, was I right? I think so. Yeah, there's a lot of stuff you had to remember. Okay, but you should have been going through it little bit by little bit every day. All right, it used to be I would say, read, one or two pages of your notes every night. Okay, that's what I would tell my students. Did anybody do it? I really doubt it. But now I can very easily say, why don't you just go back before you take the test and watch a lesson or two every night. Right? You could do that within a week, easy, really easy within a week. And just sitting there and watching the lesson being taught again, you'll remind you of the stuff that we've gone over, okay? And this will sink into your head. Instead of just hearing it one time live, if you hear it again, all right, it's going to be more likely to stick in your head. That's what you have to do. And I don't think that's what enough of you guys are doing, okay? And I shouldn't be yelling at you. I yelled at the other class a lot because I didn't yell at them, no. Not really yell, but, I exhorted them. How's that? Okay? To do better and to study a little harder. So let's keep going. JGH, where's that? That's this big old arc right here. Okay, so it's that arc right there. That's the arc that we want to find. So how in the world do we find that arc right there? Well, look at the angle that cuts off that arc. It's this one. This is an inscribed angle, isn't it? So the angle is what of the arc? Or the arc is how much of that angle? It's twice as much. The arc is twice as much as this angle. So what do I have to do? I got to find this angle.
Just add all
You could add them all up, but it would be easier to do this. find this one, and then whatever that angle is, take it away from 180, and that's this one. Make sense? All right, so we know this. So we already know 2x. We already figured it out. It's 85. Take away 10, and that's what? 75. So 180 minus 75 is what? It's 105, isn't it? Did I do the math right? That should be 105. So what is this then? It's twice as big as this angle, so it's 210. Again, remember I said the math, the arithmetic that we have to do on here is minimal. It's not that difficult, but you have to know the relationships. That's what geometry is all about. Knowing what is equal to what is supplementary to what. That's what we're trying to learn here. The arithmetic is almost insignificant, isn't it? For the most part. I think it is. Quadratic formula maybe is a little bit involved, but for that, that's that. Okay, let's no, I didn't even have that on the test. How about that?
Thank God.
All right, now look. Listen to this. I'm gonna actually jump down a little bit because 9 through 15 is on the other video. All right, so I'm not going to repeat these. You can look at the other video to see 9 through 15. Okay, so let's jump down to 16. All right, and then we'll move on from there. All right, let's take a look at this one. Use this mauve. How do you say it? Mauve. Gray, or not gray, but ugly. All right, mauve, I guess. I've heard people say mauve. I don't know. All right, let's see. How would we do this? Look, these two secants intersect outside the circle. What's the deal with that? The angle is equal to half the what? The difference of the two arcs that it cuts off, right? So let's look at the two arcs. It would be this one right here, which would be how much? 45, minus this one right here. So our only deal is we've got to find out what that is, don't we? It shouldn't be too hard, should it? Because look, from here all the way to here is 180. So if I want to find this little bit, what's this? That's 155, right? From here to here. And then this little bit is going to be 180 minus 155, which is 25. All right, so that's 25 right there. Okay? Makes sense? So it's this arc, or this angle, sorry, is equal to half the difference of the two arcs. So that's what? 20? Half of 20 is? 10. Done. Easy. All right, here we go. Yeah, this wasn't too hard, right? Again, you just have to know what the formula is, okay, or what the theorem tells us. It tells us that it breaks these secants into two parts, two segments, and what's true? The product of these two segments equals the product of these two segments. So let's do that. It's going to be 2x times 2x. I'll just do all the work. You could have probably done that in your head. But 2x times 2x equals 20 times 5. Agree? And what are we going to go? We're going gray, aren't we? Okay. So let's see what we get. What is this? It's not 4x. What is it? It's 4x squared. I had several people put just 4x on this. Equals 100. Divide by 4. X squared is 25. Take the square root. X is 5. You're done.
Oh, I thought it was 2x squared. That's why I
2
put
times 2. It's this times this. You got to multiply the 2 and the 2. And the x and the x, right? All right? Let's keep going. Here we go. Ready? On this one, we have a tangent and we have a secant. Again, you just have to remember what the rule says. The rule says, and I wrote this out. I thought I wrote this out so nice and easy for you to remember. Remember the outside times the what? What did I say? The whole thing. Does anybody remember it that way? That's how I remember it. It's the outside times the whole thing. The outside is 8. What's the whole thing?
8 plus x.
It's 8 plus x, right? Or x plus 8. It's not 8x. It's x plus 8 or 8 plus x. Equals, what do we do with this thing? We square the thing. All right, so it's 8 squared plus 64 equals 81. So 8x equals, what is that? Is that 17? Okay, watch. Divided by 8. I don't know the fascination again with the calculator. I would just leave it like that, and I'm done.
I always forget where
Simple like that.
Because like in elementary
Okay.
school, it's always
Yeah, but it's been a long time since elementary
I know,
school,
but even
okay?
last
All right,
year,
break the habit, all right? In this class, it's fine to write it 17 over 8. Really, in any algebra. Of course you can, but you don't have to. My point is, listen, you can write it all kinds of different ways. Listen, please. You can write it all kinds of different ways, but this is, look, you're doing the math, right? You just put 17 over 8, boom, you're done. It saves you. Every second of less work you have to do, the better, right? Okay, let's keep going. Let's try to get this done so I don't have to do another video at home. So let's take a look at 19. Look what they do. They give you
Is it
I almost cried.
Did anybody-
Literally, I almost cried when people would miss this. And I mean, it's not just like missing it by a little bit, by a sign. I get that. I could see that. Okay, but oh my word! I mean, there were numbers that I have no idea where they got from this. I mean, it was crazy. I couldn't believe it. So, the center of the circle. Look, all you got to do is look here and look here. But remember what the equation is. It's x minus, right? So to get plus 2, what would it be? It'd be x minus negative 2. So what's the x? It's negative 2. And this is y minus, right, the k or whatever, so it's just a 7. That's the center. The radius, remember, this is r squared, right? So if I want r, what do? Just take the square root of it. Square root of 81 is 9, and that's it. That's all you have to do. Look, this one is just the opposite. It just goes the other way. They give you the center and the radius, and you just have to write the equation. And it says the radius is 7. So look, it's going to be x minus h. So x minus a negative, which is plus, correct? Squared, right, Chris? Plus y minus a negative, which is plus. I think that's the only problem he missed. He just forgot to put squared right there. Okay? I think, is that the only one you missed? Forget it.
No, it's not.
Taking too much time. I thought I was pretty clear on that. Anyway, so look, you could keep it 7 squared if you wanted to. I'm fine with that. I don't care. If you write it as 49, of course, that would be fine as well. All right? But that's your answer, and that's it. That's the test. In 2 videos, all right, I've got the whole entire test. It's kind of a little disjointed because the other video starts at number 9 and it goes to 15. This one jumps from number 1 and it goes all the way to the end, leaving out the first one. Okay, but anyway, you can see every problem on here on this video.
Number 14.
Number 14.
Yes.
Do we have time?
14 and 15. That's what I'm
All right, I'll do 14 for you.
I got it. Can I say how you did it?
Where is it?
Are you guys watching?
Uh-huh.
So here's a point outside the circle. It's tangent right there. It's tangent right there. You guys listening? This is x. This is 35. Now look, what if this x wasn't x? What if it was 100? How would you find... We'll just mark this so I can talk about it. How would you find arc ABC? If this was 100.
Multiply it by 2.
This whole arc right here. If this was 100, how would you find this arc right here? Come on. Right, take it away from 360. But you don't know it's 100, do you? Okay? You know it's x, but you still find it the same exact way. All right? 360 minus x. That's what this arc is. I hate to say confronted. That's probably a little bit too harsh, but somebody in the other class seemed a little upset with me that I would expect you to figure out that was 360 minus x. Do you think that that's out of your range of possibility to figure out that?
Because you threw us off by giving us an angle.
I
No.
got that one right.
Okay. So now what do you do?
Yeah, the angle was
The angle is equal to what? It's half the difference of the 2 arcs, right? So this arc is 360 minus x, and this arc is minus x. And you just do the math and you solve for x. Okay? How would you do the math?
I just took 180 minus.
180 minus 35.
Well, you have to see because 360 divided by 2 minus 35 and plus 30.
Yeah.
How is
So anyway, watch. You multiply by 2 to get rid of this, so that's 70 equals 360 minus 2x, right? Add a 2x to both sides, that's what I would do. Subtract a 70, and what's that, 290? And then divide by 2, and that's 145, and that's what the answer is. Okay? I don't think that's out of your range of possibility to do that, do you? Because here's the example I gave. See if you agree with this. Didn't I give you stuff like this towards the beginning of the year and said like this was x? What would this angle right here be if that was x?
180 minus x.
Okay, well isn't that the same exact type of thing? Absolutely, except for a circle, right? Okay, if this is x. What's this? It's 360 minus x, right? So we have talked about this kind of stuff before. Don't you think that I should be able to expect you to figure out that that's 360 minus x? I think that's a reasonable expectation. I really do. Okay. All right, enough of that. It's already about 25 minutes, so I'll stop. And watch it. We're going to take a retest for those who didn't do corrections. We're going to do a retest on Monday.